we'll go to our PFAS pilot study update, and this is a presentation.
So this evening, our topic is the Seguasa PFAS pilot study update. We have a presentation for the board and for the public this evening. So in July 2023, Seguasa hired engineering consultant CDM Smith to assist us with meeting the PFAS regulations. CDM Smith was tasked with creating a PFAS pilot testing program for Seguasa. And the PFAS pilot testing program is associated with an existing CIP known as 101-07 at a total cost of $500,000. Seguasa applied to the North Carolina Department of Environmental Quality, the NCDEQ, for grant funding for this program and was successful in receiving $500,000 in grant money for this project. The PFAS pilot testing project started in October 2024 and is scheduled to be completed in the summer of 2025. The results from the PFAS pilot testing program will be used to provide the criteria for engineering design and construction. At the previous board meeting, March 11th, 2025, during a discussion about a brief overview of PFAS technologies, I provided a brief overview of the various technologies being used to remove PFAS from the drinking water. During the overview of the various technologies being used to remove PFAS from the drinking water, I asked if the board members would like to receive a more in-depth presentation from CDM Smith. The board members agreed that they would appreciate a presentation. And so here we are this evening with a presentation by CDM Smith. So this evening, I would like to introduce members of CDM Smith. Reed Barton, would you please come forward and introduce yourself for the record?
All right. Thank you, Mr. Shore. My name is Reed Barton. I'm a vice president with CDM Smith in our Raleigh office. And I have actually 3 staff members, but 2 that will be presenting today to you. So with us, as Mr. Shore mentioned, and I know that it can be frustrating at times, projects that involve major infrastructure and major changes often take a lot of time. Making adjustments at a water treatment plant are very significant and have big implications. So the state requires that they be studied fully before they're done, as I'm sure everyone understands the implications of making tweaks to water that then goes out to the whole community. So we are on a path now to study and then recommend, and we're pretty far along that path to coming to a firm recommendation of what treatment technology would be best for your water treatment plant. We are not there as of tonight, so there'll be another presentation in the future where you'll get a more firm answer. Tonight's just about giving an update, answering questions that you may have. So with that, I'll introduce Bill Dovigan and Mike Poulios. Mike Poulios is the project manager for our pilot study team, and Bill Dovigan is our water treatment discipline leader. Both deserve good introductions. I will say Bill has been I'm not sure the right term to put to it, but Bill is one of the most experienced water treatment designers in the Mid-Atlantic and South region. And very happy to say I've had more than a decade to work with him, and very happy for you to be able to ask him any questions you have tonight about PFAS.
Thank you, Reed. The next slide, please. So I'm going to begin with a brief update on the regulations. Many of you may already know this, but just for good background. So the rule was finalized in April of 2024 for the PFAS, and I'll explain which ones are regulated here in a minute. So in April of 2027, you have an initial monitoring deadline, and then April 2029, you have to be in compliance. So what's that mean in compliance? It means you have maximum contaminant levels that are enforced that you have to comply with, and I'll show you those levels. And it's annual average monitoring, like you currently have for THMs and AJAs. So that means in summer of 2028, you start the monitoring that you will have to be in compliance with in April of 2029. Okay. And they do have a reduced monitoring provision if you go 3 years with very low numbers. Next slide. So the limits in the PFAS regulations, the 2 that are most pressing for you are PFOA and PFOS. if you look at the PFAS compounds on the leftmost column, PFOA is the top one. That's perfluorooctanoic acid. And PFOS is perfluorooctane sulfonic acid. So these compounds are long-chain perfluorinated compounds. So they last in the environment a long time. I could go on too long, but I'll keep it short there. So the maximum contaminant levels that were promulgated are 4 part per trillion for each of those. Very low numbers, but it's health-based, scientific-based. And they do have the significant figure requirement of 2 to be very exacting. So in the example you see on the right of the slide, if you have a value of 4.04 nanogram per liter, running annual average, you're in compliance, but 4.05, 4.06, you're exceeding. Whereas with the other limits in the rule for PFNA, PFHXS, Gen X, all limited at 10 nanogram per liter, they only have a significant digit of 1. So in the example, you can see you can have 14.9 and it's rounded down to 10. So it's quite different. And then they also have a hazard index, which is explained in the figure at the bottom of the slide, where they take the concentrations of 4 compounds and divide them by their health-based water concentrations and add them up, and that has to be less than a value of 1. The significance of that is they're going to keep adding compounds in the future. So you can expect that in 20 years from now, there'll be quite a few more of these PFAS compounds regulated by adding them to this hazard index. But for right now, what you're having to deal with, the most restrictive aspect of this regulation for you is PFOA and PFOS, as we'll show in just a minute. Next slide. So this is your data for raw water, untreated water, before you've added any powdered carbon. You all do take out some of the PFAS already by adding some powdered carbon. But your raw water, as shown both graphically on the right and with numbers on the left, exceed the current limits that will be effective in 2029. So you're not exceeding anything right now, but in 2029, you have to get down below 4 for PFOA and 4 for PFOS, whereas they're currently at 10.2 for PFOA and 26.1 for PFOS in the untreated water. And you can see that graphically on the right. The limit of 4 is shown with the green dashed line, and the bars going up are your concentrations. The upper graph is for PFOS in nanogram per liter. And you can see it hovers around 20 to 30 nanogram per liter for PFOS in your source water, whereas it hovers around 10 to 12 for PFOA. So you need treatment. Next slide. So what treatment technologies work? Well, granular activated carbon does work. You already add some powdered activated carbon to your raw water. Granular activated carbon after your filters would work quite well. Some plants have that already, as I'll discuss in a moment. But granular activated carbon could be added at your plant with post-filter contactors. And that is what we're pilot testing right now. We are also pilot testing ion exchange because that can work and sometimes be more effective, particularly for short-chain compounds. So we'll compare those when we get the pilot data, enough pilot data to make conclusions. We're also looking at novel sorbents, which are fairly recent, hence the name novel, discoveries of ways to remove PFAS compounds. The novel sorbents work pretty well for the long chain PFOS and PFOA, not so well for the short chain. So we'll summarize all that in the report and make recommendations and compare them in many ways, including costs. We cannot compare O&M operating costs right now because we don't know how long they will last. That's what the pilot testing tells you. How long will it last? Next slide. So at Pittsboro, as an example, I mentioned that some plants in North Carolina already have this technology. Pittsboro had high levels, like many in the Cape Fear Basin, high levels of PFAS. So we already designed, built, implemented these GAC contactors that you see, these are in operation, and we did the design and construction and startup operations, and it's working very well. These are with GAC, but we designed these where they can actually work with ion exchange also and novel sorbents. It's the way you design the internals of the contactor.
Can I ask a question?
Yes, sir.
What are their current numbers?
Oh, they can meet the 4 and 4 right now. Good question. Yes,
what is their daily output of water compared to ours?
Yeah, so Pittsburgh averages about 1 mgd. If you want one that's larger, Wilmington, way down at the end of the Cape Fear Basin, they're doing post-filter GAC, and they're a larger plant.
Thank you.
You're welcome. Any other questions? Okay, I'll turn it over to our project manager.
I appreciate you guys having us here today. Let's go to the next slide, and we'll jump into the pilot update. So this is what we've been doing. We started with you guys planning a little before August, got to work early. We implemented the contract in August. You can go to the next slide. And, we got running. And this all started early on last year when the state started giving out $500,000 grants to municipalities, authorities, anyone willing to treat and start planning for PFAS for public water. And we jumped on that bandwagon early. We pushed, we received the grant, and we got the pilot up and running much before many others in the state, which is great. And we finally got that pilot running in October. So we started in August. We had to procure materials, order it, set it up, and it's working great. Like Bill mentioned, we did the granular activated carbon. We're testing the anion exchange resin and the novel sorbent. And that picture on the left, what you see there is you see the 2 larger black columns. That's the GAC. And then there's 3 more columns. We're doing a couple of configurations, which I'll explain later. But those 3 columns on the right are anion exchange, novel sorbent, and anion exchange again. And the objectives of our pilot is we're trying to run it long enough that we can determine costs. So with any type of removal technology for PFAS, we use a media. The media adsorbs the contaminants, and then it becomes spent. As an engineer, we want to determine how much we can absorb in a certain amount of time before media change-out must occur. And that's what's going to get us the best life cycle cost. So every water source is different. There's, the water chemistry changes per your source, through your distribution system. So we want to make sure we're getting it right. So the state allows the pilot study, which allows us to determine the best treatment based on both cost and efficacy.
I have a quick question.
Yes.
The media would be the compound that you're using to purify
Correct.
the water.
Yep. So the media, it's like, in this case, it's the GAC, the exchange resin.
What happens to that when it's used?
That's a great question. So a lot of it, the GAC people, they sometimes you can return it to them, and they will remanufacture it to be reused somewhere else. So, and most of the time, the other stuff is typically landfilled, incinerated, other items. But there is a waste product associated with media
like
change out.
lithium on solar panel.
Yeah, exactly.
We're all going to have to deal with. Okay, thank you.
And some that landfills are challenged with the same type of PFAS removal that we are on a different level. So that's the pilot. So next slide. This kind of gives you an update of what I'm saying. So we're looking at the columns. We want to, test a lot of different configurations to make sure there's not just one solution. So what you can see on the left there is our GAC columns, the 2 black. And the reason there's 2 is because you have to have more GAC media compared to the others. That's just the chemistry of the removal sites. And then in the middle, the gray column is the fluorosorb, which is our novel sorbent, and the yellow is our ion exchange, which is the DuPont Amberlite. And what's unique about the left is a lot of times we'll do lead lag configurations, which means we'll have a vessel that's treating the first hit, and then we'll have a second vessel in series behind it. And the reason that's important is when we start doing cost iterations, we can start determining that we can absorb as much contaminant in a vessel and then have a backup, like a buffer on the back end. And what that does is it allows us to have a sample point in between and making sure we're getting 100% use of that media. Otherwise, we have to calculate how far over are we going to be the MCL to make sure we change out that media before it creeps over. So you might only get 90% of your media use. This way, the lead lag configuration has a higher capital expense, but has a lower operating expense. So when you do the 20-year life cycle and you compare lead lag to just a lead vessel, you might find out that it is affordable and it is something that can help you. And if it's not affordable at this stage, there's ways to plan for it in the future. All right, next slide. So this is what I mentioned before. We were up and running October 2024. And I really want to reach out to Scott and Chris, and especially the plant staff. When we set up a pilot, it's not only dependent, for the engineering firm, us to be out there ensuring that it's running correctly, collecting samples and equipment, but there's a daily task associated with this. I mean, for a successful pilot, it has to run. We have to check it every morning, afternoon, evening. And we want to keep, the cost down. So instead of us being out there every day, the plant staff has been really great. They've done a great job recording data for us, and helping us out and making this pilot successful. So that means that $500,000 grant we received from the state's being stretched over that 10-month period. And so it's really good collaboration. Really happy to report that. And, the best thing about the pilot is we're seeing successful results in all three medias right now. And then, the next phase, we have to get enough results to start the design phase. So we're getting close. I believe we're going to take another round of PFAS samples this week. And based on that, we'll get results in May. And we're going to have an interim report for Scott and others, either end of May, beginning of June. And that's going to start leading us to some preliminary treatment selection. And then we're going to run that all the way through the end in October. And then come November, we're going to have another presentation to the board that says, this is what the pilot told us, this is the results of the 20-year life cycle, and this is the technology we're recommending as the engineer to Seguasa.
That was November, correct?
Correct, yeah. And it's next slide. I think I jumped the gun, so next slide, there we go. That's quizzing you. So there it is. So we're going to summarize all this in a pilot report. So we have to submit the report on October 19th to the state. That's one of the grant requirements. So that once that report's complete, it will be available to the board and other members. And we want your chance to review it, and then we'll set out the time, next board meeting, to review those results. Next slide. So this is the good part. This is the presentation of PFOA. As Bill mentioned, the critical parameters we're watching are the PFOA and the PFOS. So you can see it that actually the raw water concentrations are starting to trend downwards. I think as people in the industry and the state, we're removing PFAS point sources. Industries are polluting less. So we're seeing those concentrations go down, but not away. So you can see that top dashed blue line represents the PFOA concentration. And it looks like it goes to 8, which is about double the MCL that's going to be enforced in April. And then you can see the black triangles represent what's coming out of the plant currently. We're getting pretty close. I mean, you're reducing it almost there. And then the bottom lines, the black, blue, and those dashed lines at the bottom represent our treatment technology. So the circle there represents the GAC. And the blue is the novel sorbent, and the ion exchange is at the bottom. And it's showing that all treatments are working great, 130 days after startup. Next slide. And similar with PFOS, you can see that Bill mentioned around the 20 to 30 nanograms per liter. We're seeing it started off around 20, and then the winter months we saw it dip down, but I'm sure it's summer, more water's used. Rivers are flowing faster, we might see some uptick there. But again, you can see that the plant currently is removing. It's not passing it through. The PAC that you're putting in there is doing quite a bit. It's looking like it's knocking, 40 to 50% off. But we still have more to go. And it's showing below that red bar is the MCL. We're showing that all three technologies are successful at removing this compound. Any questions?
So the Calgon, the Amberlite, the Fluorosorb, those are all different. You're trying to find the best system out of all of those three?
That's correct.
I guess there's a fourth one.
Well, the fourth one is the Calgon, followed by the Amberlite, that lead black configuration. We're trying to see if there's any advantage that Amberlite lasts longer if you have a GIC that takes the front hit.
So you were saying that the media goes to either be recycled or it can go in a landfill. it goes into a landfill, doesn't it affect the groundwater and cause more PFAS?
Correct. So landfills have their own challenges, right? So they are, landfills are capped and lined, so they contain the water, and water is removed, and they have their own treatment systems, and they are tasked right now with the same as trying to remove PFAS.
Okay. Just want to make sure we weren't giving it to them and starting this all over.
Right, yeah. And that's what's interesting. There, new technologies are developed every day. And that novel sorbent, they're actually using, not in landfills, but for groundwater remediation as well. And they know plumes going through, they're actually building, instead of putting the media in a vessel, they're building walls in the ground that help knock it down. That's completely out of this picture, but that's something, we're seeing in the engineering world.
I appreciate these two charts, the one before this and this one, because it does show that there is progress being made, and
Absolutely,
we're not just up here
yeah.
saying things are being done, but now we can see that it is, and it's quite amazing.
Yeah, and we're in month 6 out of 10 of our pilots. So I mean, we're moving fast, and I think for us as the engineers, we see Seguasa and their willingness to make sure this happens fast.
Yeah, but based on these charts, what we're putting out presently to our customers, the sky's not falling, but we have ways to go.
Correct.
We have ways to go, more work to do, but it's not. Oh no, the sky's falling. We got 10 times the allowable limit going out.
Correct. Yeah, you're showing that you're reducing the plant, and that we found treatment technologies that will be effective in treating the PFOA and PFOS.
So from looking at this chart and the chart before, are you pretty much saying the novel solvents pretty much bringing it down to almost nothing once it's treated?
Well, we're showing that right now. There hasn't been a breakthrough, I think, at this point, and I think this goes back to our February sampling. And we're getting our March results now. It's always a month behind. But what we're showing is that the Fluorosorb and Amberlite, the novel sorbent and ion exchange haven't shown breakthrough yet. But the GAC, we saw initial breakthrough, but you can see it's just been hovering. It's kind of reached a steady state. If you go back a slide for the last few sampling events, you can see where it's hovered at 2. So
Right, so it's brought it way below the mandated
correct.
4. So,
but I think when you look at capital costs, each media, GAC media might be less expensive than the ion exchange media. So when you start looking at life cycle costs, ion exchange can become a better selection if you can get it to last longer. And that's what Reed mentioned, or Bill mentioned, the point of designing these vessels, not for one media, but for, all 3. Because as things change in the future, they add more components, short chains, things like that. It allows you to start analyzing different types of media, and it gives you the option to change to what best fits the media.
so going back to a few slides to Pittsburgh's system that was designed and is currently in place.
Correct.
How often does the media have to be changed out in their system? I know, like you said, all systems are different. All systems are, based on the area that they're in.
So I guess Bill.
Pittsburgh went over a year and with very low levels before they had to change one of the. Every job is site specific. So your numbers you'll hear once we have the results in for the pilot test. But very favorable results in their case.
What was the construction time?
We built what you see there in less than a year. We went from 60% design to online. Can't guarantee that, until we study your job, but that's what we did there.
That was through an alternative delivery, design build versus design bid build. So it allows you to escalate schedule.
Can you repeat that, please? It was a design to build?
Design build.
Okay.
So the Bill mentioned it's 60%.
As opposed to design, then bidding to different contractors
Right.
and then building. With design build, you have the same group doing
Right.
both design and construction. So you're able to speed a lot of it up by overlapping tasks.
And I think that's what we discussed, right? One more question.
Yeah.
What was the results when you first started at Pittsburgh as far as the range it had for each of those?
What
Was
the
it very
raw
high?
numbers?
Yeah.
Raw numbers. As
The
soon
raw
as you put
numbers.
those on, the levels drop tremendously. Very similar to what you saw at the start of your pilot testing.
Okay.
Yeah, and I think what we're seeing here at the pilot testing, I mean, like Bill said, it initially knocked it down, most all of them to non-detect. And so if you go to the next slide, I guess it's slide 15, we see some hexagons. There we go. So these are the hazard index compounds. So what we've noticed that there's been most of these compounds were either non-detect or below the MCL in raw water samples. And essentially what we're seeing, you know, when we do the pilot studies is that most of them were non-detect and some were, you know, at the method detection limit, which means the analytical instruments the laboratories have, I mean, they're just picking them up underneath us. So, you know, our confidence in those numbers, you know, pretty much non-detect because they're lower than what they can detect. So we're showing that the pilot's knocking out these hazard indexes as well. And the only thing we haven't really seen come through is Gen X. I mean, that has been 0 coming in, 0 going out. Wow. Excellent. Thanks. All right. So funding update. So we came up with a planning estimate early, you know, based on very limited information. We needed a planning estimate to start requesting funds. So we came up with this planning estimate to prepare for SRF funding. We've gone through 2 cycles now, and we will be applying for the 3rd this April. And the further you get down the design process, the better your chances are. So us having a pilot that's more than halfway through will hopefully give us a better number. And I say number, but they have a score sheet where they give you a better score that'll maybe outcompete some other communities who haven't started pilot testing. And as sure as you guys know, we've secured a $5 million grant. Well, Scott secured that from state appropriated funds in 2023. So that's being applied to the PFAS. We worked with the state, aligning that money. We've received approval and we're going through the intent to fund that now. So there's some paperwork that needs to be done, but that is going to be unlocked and that money can be used to start the design process. So we're doing this so once we finish piloting that there's no stop, that we continue this project, you know, foot on the gas. And then at the bottom is the future SR funding. So they do a fall and spring application. We're in the spring application now, but we are going to keep applying and get as much money as we can for Seguasa. Any questions?
Do you see new technology coming out?
Oh, absolutely.
Other
All
than
the time, yeah.
these 4?
We see new technology and we make sure we're apprised of it. And even this one, there's a local company in North Carolina that thinks they have a media that can be used, but it's very hard to get enough of the media to pilot test. So when we hear new things, you know, if we can fit it in, we will. If we can get it in a nearby resource or do something, it's helpful. But I think the good news for you is as we design these contactors in the future, and once they're up and running, you have the ability to even pilot test different money. So as with anything, you can optimize treatment. It's always something. So as new media comes out, that's something we can test. And you also have the growth component. So we're trying to design these systems to be modular. So treat your capacity today and expand for future capacity. So if there is a newer, better technology for that future capacity as you continue to grow, you can use your capital dollars to spend on that better technology. But we're designing around the best technology we know about right now.
So the 5 million he was talking about, that's the 5 million we just got the approval from DEQ for PFAS.
That is correct. We received a letter with an intent to fund the project. To move forward with that process, there's a required resolution from the board, and you will see that at your upcoming meeting, basically the meeting in May for that. So that will complete that packet, and we can send that back to DEQ to continue with that process to support this project.
Wonderful.
Okay.
Yeah, and we show the 4,925 there because there's a fee associated with administration of the loan with the state.
$75 for a letter?
No, $75,000 is a cut.
75,000 is insane.
It's a lot.
I'll write a letter for 75,000.
Your letter will as good as
Next slide. So, looking at the project schedule, you can see on the right hand side, bottom right, April 2029 is our target date. If possible, we want to beat that date. But going through, walking through this, I mentioned we're in our 6 month out. We're doing some sampling. We're hoping to get that sampling and start some preliminary cost estimates so we can look at a preliminary treatment selection in May. We want to say, based on the results, these two technologies, this one technology appears to be the best on the pilot. And we want to get that in your mind so we can start thinking about some early design methodologies, items that we can escalate schedule. And then we'll complete the pilot in October. And when the pilot's complete, we will have a board meeting in November. But the purpose of that pilot report is also to select the final treatment. So in that pilot report, there will be a conclusion in October 2025 that states of the 3 medias we tested, which one, as an engineer, we recommend based on cost and efficacy. And then from there, if we started our final design in January, there's going to be some master planning items that have to happen from October to January, looking at the plant facility and where best it is to put this system. And once that's decided, design will start. And if it's the design schedule, bidding, permitting, all that, we're aiming to complete that by March of 2027. And that's just a very high level schedule right now. None of this is set in stone, but this is kind of the worst case schedule that showing that we can meet the proposed April 2029 deadline. And then our goal is to award that construction contract in 2027. We anticipate it being a 24-month construction period. So there's going to be, right now we're seeing 6 to 12 months to secure and procure materials, whether, it's the vessels itself, electrical equipment, whatever it might be. That'll happen. And then there's probably going to be, during that procurement timeline, there'll be civil work going on, buildings being constructed, and then typically the last 12 months of construction is installing the treatment technology, and then the last month being a startup. Any questions on schedule?
Yeah, I don't want to wait till 2029. I would like to move forward as soon as we find out our results.
Perfect. I think that's everyone's feeling is let's attack this as quick as we can.
I mean, especially if we were able to do the Pittsburgh project in under a year.
I agree.
It seems reasonable.
Yeah, 2029.
That's reasonable, but we have to come up with the money.
Yeah.
Yeah.
That's the part.
I'm asking all the time.
You need to start looking for the money very hard.
We've been looking for it. We have been looking for it at the state level, the federal level. We were in talks last week with at the Senate level, and we talk every week to somebody.
Commissioner Ways reached out to federal level to try and get some funding. Isn't that right?
Yeah, spoke to Senator Tillis' office.
Yeah.
Maybe we all need to do that.
Yeah.
Yeah, because we at the county level
We can't
with
go all the way
Tillis
with just our
and
information
Bud's
then
office.
no funding.
Yeah. Yeah, we've been working with both representatives from both offices. You never get to talk to the senator themselves,
Right.
but you get to talk to their people.
Yeah.
And we're working with our people here in the state.
So can this be expedited, or is funding the reason we're holding back?
We're not done.
Majority here. Yeah, I was going to say. Thank you, Mike. Yes. Okay. On the mic. There we go. The question was, can it be expedited? The answer is yes, but there's a couple factors that are very important for expediting it. One will be of the technology that's being picked. So PFAS is affecting about 20% of the utilities in North Carolina,
Some states are higher, but if you imagine that across 50 states, the type of equipment that's used to treat this is in hot demand right now. There are long lines forming around ordering this equipment. The contracting community that installs it is obviously very busy. So my advice to all the utilities that we have been working with in this capacity is that the sooner you're in movement on construction, the better, because there will start to be a line formed. And I will say that the message from Scott throughout this project has been we need to move with speed. And I know Scott's been very cognizant of the fact that lots of utilities are facing this same regulation, sitting in the exact same way. In North Carolina alone, our firm has done 16 of these pilot studies, and we're only one engineering firm. There's a lot of utilities impacted by it. So one of the ideas that is being discussed is design build. Design build is where you take what is a process where you do design, you get a permit to build that, you hire a contractor builds it, and then at the end the engineer certifies it. That's your typical way of building an infrastructure project. Design build is an alternative way of doing it, and I say alternative, it's very commonly used on plant projects, water plant, wastewater plant projects, but you are able to overlap. While you're designing, your contractor is in the room giving ideas, so he's not giving his bright ideas after it's already built. And you're obtaining permits while the contractor is ordering equipment and having things delivered to the site. There's a lot of overlap. So the Pittsburgh was mentioned tonight. That was a very successful project, similar to the communities here. The town of Pittsburgh was very concerned. They weren't waiting for an MCL. They were very concerned about the levels in their water, and they wanted it fixed as soon as possible. So they did a pilot study. They got to similar to where you were, where the pilot study wasn't fully done, but the writing was on the wall on what the best treatment technology was. They immediately went forward with a design build RFQ, selected a design builder, and spoiler alert, that was our firm. And Bill mentioned it was constructed in 12 months. There was a little bit of design before that. The full schedule, I believe, was 18 months from where we stopped piloting, and then we had water running through the granular-activated carbon system and achieving non-detective PFAS on day one. So it was honestly, it was a very happy day. Media was out at the water plant, and the town was able to make an announcement. We've been running it for 1 week, and we have no PFAS in our water. So it's very exciting.
All right. So what I understand, coming up, you'll have your 6-month pilot testing complete.
Yes. Each month we run a comprehensive set of lab sampling to see how everything's doing. So as Mike mentioned, we just sent off all the shipment of samples to the lab for March, but we don't have it. We don't have that data back yet.
You want to do a 12-month pilot, correct?
Yeah.
So can you come back to us in a month whenever you get the final, the 6-month, and where you think we should file?
I don't know that the data is going to tell you anything different just 1 month from now. What we'd recommend is that the word breakthrough has been mentioned a couple times today. That's when you're looking at the data and for months, no PFAS is getting through the adsorption media. All of a sudden, 20% is getting through. And then the next month, 40% is getting through. And that curve of getting to where 100% of the PFAS that's coming into the treatment is now passing through, that's what we call a breakthrough curve. Right now, almost all of them are removing a substantial, if not 100% of the PFAS. Until there's a breakthrough, we don't know which one is going to outperform the other. Gotcha. And it can be a pretty significant cost difference. If one sorption media lasts 8 months and the other one lasts 11 months, when you multiply that at the scale we're going to build it at, millions of gallons of water a day, 365 days a year, it can be a pretty significant cost difference. So we're looking for the most cost-effective way to remove a broad spectrum of PFAS. And that's the target. Scott and Chris and the team on staff have asked us, is there a point where we can start the beginnings of design, even when we maybe have a month or two left, if we start to see that breakthrough curve forming? So professional judgment is 2 to 3 months from now, we're going to have the answer. I believe if Sigwasa would like to, we can begin design at that point. Obviously, you don't want to get too far down the design road until final decision's made, but you can get a little bit down the design road. Scott, anything to add to that?
No, I think it was a good summary. Thank you.
Okay.
Pittsburgh, what were the levels they were experiencing in the intake?
This is Bill. This is jogging our memory back to
Yeah.
2018, 2019. So as Mike mentioned, some of the levels in the river, in everybody's rivers, has been coming down a little bit, and I think it's because this topic is getting so much attention. The state is putting more pressure on industrial users and what they put back in rivers.
I've read some
Pittsburgh was in the
pretty
hundreds.
astronomical numbers there.
It was well over 100. It was like, depending on the day and the time of sampling, it would go up and down. But there were samples that were well over 100 of PFAS and PFOA.
And then it dropped as the years went on, like
Yeah.
most people are saying.
Yeah.
One other thing, if I could add, Reed mentioned how we had that 1 year of construction, and we had about 6 months of design before that. The other trick that is needed is to order equipment, your long lead equipment. And we did that for Pittsburgh as part of the phase 1 of the design build. So you have to have your contract for design build, and you have to have the money to order the equipment to get that super fast schedule.
Okay.
Yeah, that's a good point. So I don't think we're the only company doing this, but some companies, including ours, who work in this industry, have pre-ordered the materials to build these vessels. And we did so years ago. And it's so that we can make them very, very quickly. And we're doing that nationwide. We have fabrication shops in Florida and in Denver. And the purpose is because the feelings you guys are having right now around this topic is going on everywhere.
Mm-hmm.
And it's not uncommon. And finding the materials to make this, as Bill said, you could just order steel and wait 6 months for it to show up.
So May 25 preliminary treatment selection, and then 5 months later final treatment selection. Is what is going on during those 5 months that we have to wait those 5 months before we can move on to the next step? Are we just testing the preliminary treatment that we chose?
There is an opportunity to proceed with beginning design work in that interim period that you're describing. I think it would be good to start to see the breakthrough curve before you actually start having designers put pen to paper. But as it's beginning, I think it would be fully reasonable to start design at that point.
But if we hit that breakthrough curve during that 5 months, we're going to come back to the drawing board and we're going to have to do something different. Or are we going to stay with our preliminary treatment?
So all of these treatment technologies, that we're looking at are going to go into the same type of steel vessel. A good way of explaining it, could we go back on the slide to the Pittsburgh slide that has the picture? Actually, that one's fine. It's got the steel vessels. This picture doesn't do it justice. These are about 28 foot tall. Each one of them holds 40,000 pounds of activated carbon. But they are a very large version of what goes into refrigerator filters. When you buy a refrigerator filter to go in your LG refrigerator, well, it won't last nearly as long as this does. It's filled with packed carbon that's been treated, and it removes a wide range of chemical pollutants. So I don't want to oversimplify it. It's more sophisticated than what goes in the refrigerator, but the technology is not all that different. This is just on a much bigger scale. I'm sorry.
It's okay.
Totally forgot the question. I don't want to keep going.
Well, if we select a preliminary treatment and we watch it and it gets to the breakthrough point, do we have to go back and select a different treatment again?
So all of the technologies that we're testing right now are currently removing substantially,
right,
most or all of the PFAS. We never say all because there's always some fraction that we can't even measure. So you can't even guarantee that it's 100%, right? 99.9.
So I believe you made the statement, everyone will have to have these two big tanks.
So
everybody that has whatever we decide will have to have these two big tanks.
Yes, thank you. Thank you for reminding me. That's where my train of thought was going. Thank you. All of the media type we're currently testing, the novel sorbents, the ion exchange media, and the granular activated carbon, will all fit in this type of vessel. The interior components of it may be modified a little bit between the two, the different selection, but generally speaking, it's the same technology. And we have big picture questions. How are we going to pump it into these vessels? When it comes out, how are we going to control the flow and make sure it gets the right chemicals added back to it afterwards? So there's a lot of design. We don't just pull this off the shelf, plug it in. There's a lot of other design considerations that we could start on early, even before we're at the point with needing to settle all the internal components within that vessel. So there's several months of design that I don't think would be wasted before October 2025.
And by what I understood, you've already ordered some of this material to build these and already have them.
And I can't say they're not spoken for because we're literally working for dozens and dozens of utilities across the U.S. But these are very commonly needed to the point that as a company, we are, before orders come in, pre-purchasing the raw materials and send them to our fabrication facilities so they can be made.
Correct.
Yeah.
Okay. That's what I understood. I just want to make sure I understood what you were saying.
That is correct.
And I believe in the earlier presentation, talking about the Pittsburgh system, it's been designed to do at least two of the medias if they have to swap it out.
The pilot study showed that it was complex because they had more chemicals than you guys have. There was a wider range. So I don't want to open a can of worm into a broader scientific discussion, but we recommended a two-phased approach where they install these in phase one because that's what they had enough money for at the time. We did recommend a second treatment after these as a phase two. The long story here is that Pittsburgh's water plant was bought by Sanford before phase two was installed, but it's kind of a moot point, right? These were for PFAS removal and they performed well from day one.
So they never added
They never added phase two. So Sanford, Sanford took, merged. They took over 3 utilities. They're in the process of taking over Chatham. They took over Pittsburgh and Siler City. So there's an administrative change, and I haven't heard if they've decided to move with phase two yet. Phase two was to address 1,4-dioxane, which is another bad chemical that can be in the rivers, but it's not in your river, in your reservoir.
Wonderful.
1,4-dioxane. It's a degreaser. It's a nasty thing. In North Carolina, unfortunately, has a big problem with it.
Where does the components for this come from?
Since
the entire world is afraid of tariffs, let's see what we can do and let us know this is going to delay it again.
I've been asked that a lot lately. What does tariffs do to construction schedules and price? The true answer is I don't know yet.
The reason I'm asking is I have got citizens that are terrified and they're worried. And we are doing everything we can, thank God, with your help. And the progress you've made already with the testing is amazing to me. It looks like we're closer than I thought we were. And I'm very, very happy that $500,000 is being spent very well, in my opinion. But if this gets delayed, I think we're going too close to the May of 2029 deadline. And if we could expedite it so that we have a bigger cushion there.
Yeah.
But supply chain